In this video, we are going to focus on dependent events. If two events, A and B, are dependent, then the probability of occurring event A and event B is equal to the probability of occurring event A times the probability of occurring event B given that A has occurred, because they are dependent. Let's check an example. So we have a fruit bowl that contains 3 apples and 5 oranges, and Callan selects a piece of fruit at random and eats it, and then his sister Michelle selects a piece of fruit for herself. You have to find the probability that both pieces of fruit selected are apples. Okay. So we have in total 3 apples and 5 oranges. So that makes 8 pieces of fruit. So let's say that Callan, we use the capital letter C for Callan, and for his sister Michelle we use the capital letter M. And in A we have to find that both, so Callan and Michelle, select apples. So the probability that both selected pieces of fruit are apples. So both are apples. That is actually equal to the probability that Callan selects an apple times Michelle selects an apple given that Callan selected an apple before. That Callan selected an apple before. So in the beginning we have 8 pieces of fruit there, and Callan selects an apple. The probability of selecting an apple is then 3/8, because we have 8 pieces of fruit and we have 3 apples in it. Then times, after Callan selected the apple, 2 apples will be left, so 2 apples will be left, and we still have 5 oranges, so in total we have 7 pieces of fruit. Now Michelle has to select a piece of fruit, so the probability of selecting an apple is 2/7. So that is 3 times 2/8 times 7. We can simplify this. We can get rid of the 2, and here we get a 4. So that is equal to 3/28. Let's do B. So there we have to find the probability that Callan selects an orange and Michelle selects an apple. So the probability that Callan selects an orange and Michelle selects an apple. That is equal to the probability that Callan selects an orange times the probability that Michelle selects an apple given that Callan selected an orange before. Okay, so in the beginning we have 5 oranges, and in total we have 8 pieces of fruit. The probability that Callan selects an orange is then equal to 5 over 8. After he selected an orange, 3 apples are still in the bowl, and 4 oranges will be left, so we have in total 7 pieces of fruit. And the probability that Michel will select an apple is then 3 over 7. So that is 5 times 3 over 8 times 7. We can't simplify that more, so that becomes 15 over 56. Let's do example 12 in the book. So example 12. So a container holds 3 banana ice blocks, 4 chocolate ice blocks, and 2 raspberry ice blocks. And George randomly selects an ice block from the container and eats it. His brother Oliver then randomly selects an ice block from the container. In A, you have to draw a tree diagram to display the possible outcomes. Let's say that we use the capital letter B for the banana ice blocks, the capital letter C for the chocolate ice blocks, and the capital letter R for the raspberry ice blocks. Okay, so first George randomly selects an ice block. So for the first selection, we have the possibility to get a banana ice block, a chocolate ice block, or a raspberry ice block. We have 3 banana ice blocks, 4 chocolate ice blocks, and 2 raspberry ice blocks. So 2 plus 4 is 6, plus 3 is 9. So in total we have 9 ice blocks. The probability to select the banana ice block is 3 out of 9. The probability of selecting a chocolate ice block is 4 out of 9, because we have 4 chocolate ice blocks. And the probability of selecting a raspberry ice block is 2 out of 9. And here George selects. And now his brother Oliver will select. Okay, he can select a banana ice block, or a chocolate ice block, or a raspberry ice block. And that is the case for the others as well. So here we can select a banana, a chocolate, or a raspberry one, and here as well a banana, a chocolate, or a raspberry one. So if he selected a banana ice block, the first one, if George selected the banana ice block, then 2 banana ice blocks are left. We still have 4 chocolate and 2 raspberry. So in total we have 8, and the probability of selecting another banana ice block is then 2 out of 8. The probability of selecting a chocolate ice block is 4 out of 8. The probability of selecting a raspberry ice block is 2 out of 8. And in this case here, if George selected a chocolate ice block in the beginning, then we still have 3 banana ice blocks, 3 chocolate ice blocks will be left, and we still have 2 raspberry ice blocks. So in total we still have 8 ice blocks. So 3, the probability of selecting a banana ice block is 3 out of 8. The probability of selecting a chocolate ice block is 3 out of 8. And the probability of selecting a raspberry ice block is 2 out of 8. Let's say that George selected in the beginning a raspberry ice block, then we still have 3 banana ice blocks, still 4 chocolate ice blocks, and 1 raspberry ice block. The probability of selecting a banana ice block is 3 out of 8, a chocolate ice block is 4 out of 8, and a raspberry ice block is 1 out of 8. And that is the tree diagram. And then for B, we have to find the probability that the brothers selected the same type of ice block. So that means, so let's write it down, brothers selected the same type of ice block. So that is the probability that George selects banana ice block and Oliver selects a banana ice block, or, so plus, the probability that George selects a chocolate ice block and Oliver selects the chocolate ice block, plus the probability that George selects the raspberry ice block and Oliver selects the raspberry ice block. So the first one is actually this. So George selects the banana ice block and Oliver selects a banana ice block. And then that's the first one. And then the second one, first a chocolate ice block, then a chocolate ice block again. And then a third one, first a raspberry ice block, and then a raspberry ice block as well. The probability that they both select a banana ice block is the 3 out of 8, 9 that we have here times the 2 over 8. So 3 over 9 times 2 over 8 plus the probability that they both select the chocolate ice block is 4 over 9 times 3 over 8. And the probability that they both select a raspberry ice block is 2 out of 9 times 1 out of 8. So we have everywhere in the denominator 8 times 9, so it's already on the same denominator. Then here we have 3 times 2, which is 6, plus 4 times 3, which is 12, plus 2 times 1 is 2. So we have 6 plus 2, which is 8, plus 12 is 20. So we have 20 over 8 times 9. We can simplify that a little bit. So we can divide 20 by 4, then we get a 5. We can divide 8 by 2, then we get a 2. 8 by 4, and then we get a 2. So that will be equal to 5 over 2 times 9, or 5 over 18.